Okay, at 6:15, let's get started, guys. So, first thing I want to start with is get you guys to introduce yourselves. So, I'm gonna start with me first, right? So, my name is Rafael Almeida. I'm 16, and I started coding Python when I was like 12, I guess. So that's been like 4 years now. I started because my cousin, he was a programmer, and he was spending like a day in my house, and he got this call, and like it was an emergency, and I went to and he like rents his computer. So I went to see what he was doing, and I was like, "Oh my God, like what are you doing? Are you hacking? What are all these lines and numbers and stuff?" It looked super cool, and that's how I always started. So, Ian, you wanna go next? Introduce yourself, say something, and tell me your experience with coding, if any.
Hi, I'm Ian's father, Dave, and
Okay.
I've done some coding and was kind of learning Python, and I've written a few programs, but
How
that
d
wasn't like my primary language. So,
Oh, what's your primary language?
I mean, I've done some like a proprietary language for an ERP system. Before that, it was a few others like a little bit of COBOL, basic,
Oh,
JavaScript, kind of a
definitely.
little of this and a little of that.
The
Mostly
mainframe languages.
SQL,
Mm-hmm. Ancient now.
right?
Uh, anyways, Aiden, you can go next.
Hi, I'm Aiden. Uh, I really started to get into programming when I first turned 13, but I've been inter interested in it ever since I was like 10.
Oh,
Uh,
okay.
yeah, I know a little bit of JavaScript and Python, not much. I've mainly been learning some of Lua. If,
Lua or Roblox.
yeah,
Okay, how old are you right now?
13.
13? Okay, that's
I'm
perfect.
gonna turn 14 in Jan March though.
Soon, soon. Okay, so, um, now we got to know a little bit about each other now that the situation's not as grim because nobody showed up, unfortunately. Not a lot of people, but that doesn't matter because now this we can make it a lot better. So I'm gonna share my screen and we're gonna start with a little game. Okay, so this game we're gonna be learning how to code it in the program like later on. So in Python there's this module called a module. It's like a packet of a bunch of stuff you can do, like a bunch of functions, a bunch of code that is already written, and then you could just borrow it, right? So this module, it's called Turtle, and as you can guess, you can do stuff with turtles, and you can draw lines, and like the turtle, moves, and then it draws a line behind it, and it's pretty cool. So the program I have here, it's called Turtle Race. Okay, so I'm gonna open it up. So this is a program, and this we're definitely gonna learn later on. Oh, someone joined. Good afternoon. Good afternoon, Pikachu 19. How are you?
Hello, this is Albert mom. Sorry, I did
Ah,
not know. Yeah, we have a lesson at 5. Yeah, so I saw that it's only 6. Yeah.
oh, so the lesson actually started at 6. Um, but it's okay. It's okay. Don't worry. We just started. I would like for let me just stop sharing my screen then. Could you introduce yourself and like tell how much experience your son maybe has? Sorry, you muted.
Oh, sorry.
That's
He
okay.
is 10 years old and
Yeah.
fourth grade. And he has some coding knowledge for the HTML and learned a little bit Python before. But I think almost forgot.
Oh,
Yeah. So
he will
yeah.
remember today. Today
Yeah,
he's gonna
he
remember.
likes the scratch normally. So yeah, play a
Uh,
lot for the scratch.
okay, that's
Yeah.
great. So he already has a good understanding of the ideas, and in Python, it's just not as colorful as Scratch, but it's definitely like the same idea and same structure. So what I
Mm,
want to start with is I'm going to share my screen, and I want everybody to like participate in this little game. So this game, it's made using something called Turtle, right? And it's going to be a turtle race. So I'm gonna open it up here. Okay, this is the game. I'm going to run it, and now it's gonna ask me for how many people are gonna play. So Mr. Thomas, Ian, and Aiden, you all want to play?
Sure.
Sure. Okay, so I'll put 4 people, and I want everybody to pick a color. Aiden, you can start picking your favorite color.
Blue.
Blue. Okay. Ian,
Okay.
can you pick one?
Ian, you need to unmute.
Yeah, have I unmuted?
Yeah, you're
Yeah,
unmuted
he
now.
was asking me a question.
Can you pick a color so we can play?
Green?
Turtle
Oh,
race. Green?
emerald green.
Emerald green? I don't know if you could do emerald green, but I'll just stick with
You can
green.
just do
I'll stick
green.
with green. Okay. I'm not sure.
I
Mr.
thought I was
Thomas.
unmuted. That I was trying to talk and I thought I was unmuted. Sorry about
That's okay.
that.
Don't worry. Mr. Thomas, what's gonna be your color?
Purple.
Purple. And finally, what color do you want?
I'm thinking about orange.
Orange. It's perfect. Okay, so we got blue, green, purple, and orange. And when I start this, the turtles are gonna get into their position and they're gonna start racing. Okay? At the end of the class, I have a little file here called results, and we're gonna see whose turtle was the fastest. You can clearly see orange is pretty fast right now. So maybe it might win. I don't know. But let's keep it at that. I'm gonna minimize it for now, and we'll take a look at it, here and there. So right now I'm gonna open this file here called my file, and this is where we're gonna start coding. Um, does everybody have Python set up on their computers? If you do, if you don't,
No, I
you can
don't.
just say it. Okay.
I
If
don't.
you do not have Python set up, I want you to go and visit this website here. This website over here called Trinket.io. Just type Trinket.io. If you don't want to download Python on your computer, that is fine as well. You could just go to this website and it's more than enough for what we're going to be doing today. So you're going to go to Trinket.io and you don't have to sign up. All you have to do is scroll down and you're going to find something that looks like this. Okay. It might have different files and some writing. All you have to do is just delete all that writing because we're going to write our own.
Yes.
I think we cannot see your screen.
You cannot see my screen.
Yeah, only white. It's a
It's
Python
only the
file.
Python file.
Oh, you only see a Python file.
Yeah, empty Python file.
Huh. Let
You might
me
need
try
to
sharing.
change your screen resolution to see a wider screen.
Yeah, I'm sharing my whole screen. Do you guys see everything now?
Yes, I
Yes.
see it now.
Okay. So it's gonna look like this. Trinket.io. You're gonna have 2 files here. I think one is gonna be called main, right? And the other one is gonna be called shapes. You don't have to worry about that. Just delete everything that's inside of main and have it blank so we can write our own. Trinket.io. I'll put that on the chat for everybody as well. Everyone, Trinket.io. Everybody set up? When you're good, just shout it out. Put a thumbs up. Say something in chat maybe.
I have my Python emulator running.
Sure. Sure, that works too. However you can run Python.
So I'm trying to figure out, do we click connect, or like I'm in and I just did the email and password and it has a whole bunch of choices from blocks to code and
Daddy,
learning.
you don't need to log in.
Yeah, you don't need to
He
Oh,
log in.
said that you don't need to log in.
All you have to do is go on Trinket.io and then you log. You scroll down. Sorry, you scroll down until you
You don't
see
need to log in at all. Like you.
got it.
something that looks like
Just let me
this.
listen to him.
It's Trinket.io, and then you can add a /Python, which brings it to the Python page for Trinket.
Okay, I see it. I just scrolled down.
Let's see. Yeah, this is exactly it. So here definitely has some extra stuff. So all you gotta do is delete all that. Just come here, delete. Okay, I guess since most people are gonna be using Trinket, I will use that as well. So I'll have it here in full screen.
Okay, I'm with you. And just so you know, my son Ian has not really coded before. So a lot of this will be brand new to him.
Okay, don't worry. This is supposed to be like I'm gonna introduce lots of things, so it might be a little confusing. If you guys are confused, especially Ian, since he is brand new to this, just ask me a question. But I kind of want to move a little fast because it's a lot of things I want to introduce from the basics up to, somewhat after that, so we can start coding the project for today. Just want to make sure everybody is ready. Everybody good? Ian got it. Mr. Thomas, Aiden. Okay, I guess everybody is ready. So
Go.
first thing I want to show you guys actually is what we're going to be coding today. We're going to be coding a very, very simple calculator. It's only going to take in two numbers in an operation, and it's going to look something like this, okay? So it's going to ask us for a number, enter first number. Not sure if it's, maybe I can zoom in here a little bit. Okay, so it's going to ask enter first number, and you can enter any number, any integer, right? Let's say 54. Please enter an operation. We're going to type add, for example. Could be multiply, divide, or subtract. And then our second number can be 46. So we get a 100, right? So it's going to display the result. And right after that, it's going to ask if you want to continue or not, right? Let's say no. So the program closes. Let's go to Trinket, and we're going to begin understanding a few topics here that we need to understand. Um, First thing I want to introduce is data types. I hope everybody is familiar with the word data. Data just means information, and data types are types of information. In Python, right now, we're going to be working with two main data types. The first data type is integer, okay? And the second one is string. You can think of string as text and integers as whole numbers, okay? You don't have to type this right now. Just follow along. So we got string, integer, and that's it. Now, how can we represent an integer in Python? An integer in Python, I'll just type that below here, is simply that number. You just type that number and that will be an integer. However, integer cannot have decimal places. That is a whole new data type, and we might talk about that later if we have time. But for right now, let's just stick to integer and string, which is text. So we got integer, which is just a number, and a string would be anything you type inside of double quotes. You can also type it inside of single quotes. So you're going to type double quote, and then inside of them, you can type anything. So this is a string. Okay? Let me just delete whatever is above here. You guys will notice that I have a string in my program, and I have an integer. And if I click over here on this little play button, it's gonna run. But you see how nothing happens? That's because I have all this data, all this information in the program, but I'm not really doing anything with it. Next thing I wanted to introduce is a function called print. A function in Python, you denote it by typing the name of the function. So this function is called print. And then you're going to open and close parentheses. Okay? And then whatever you type inside of the parentheses will be shown over here on the other side. Okay? So let's say I type a string, so I have to remember that strings need double quotes or single quotes around them. So double quotes, and then I'll type, this is a string. I have to make sure I close the parentheses, and I click run, and look, it shows over here. This is a string. For numbers, it's the same idea, but in the case of an integer, you don't have to type the quotes. Does everybody understand that? You also get 5 over here. Everybody following? Okay. Oh, one more thing. You can actually like type a number inside of quotes, right? And it's also going to be shown over there. So this is 55. This is my favorite number. It's going to be shown over here. Anything you type inside of those quotes will be shown. Anyways, continuing. Now that we understand data types and we know how to show them to the screen, I want to introduce you guys arithmetic. Arithmetic is just mathematical operations. So adding, subtracting, division, and multiplication. We're going to focus on those four, the main four, so that we can build our calculator a little faster here. So I want to first introduce these operations with integers. It's a little different with strings. So here we have an integer, 5. And if I want to add 5 to that, right, and display it on the screen, I'll put that inside of the print. I'll put 5, and I'll put the addition symbol. It's very simple. And then I'll put 10. And I get 15. Right there. If I want to subtract, put the subtraction symbol. So 5 minus 10 gives me negative 5. So if I have 10 minus 5, I get 5. Now what if I have 10 times? So this symbol represents times. I run, I get 50. Okay? And division, as some of you may have guessed, it's the forward slash. So forward slash right next to your shift key on the bottom of your keyboard should give 2, right? 10 divided by 5 is 2. Okay, now we know how to do operations with integers, which is kind of what we want to do with our calculator. But before we continue, there's a very, very tricky thing here is that if, for example, if I have 5 as a string and then I add 7 as a string, what do I get? Right? Can someone tell me?
57.
57.
57, okay.
It's a string.
Aiden, do you agree? Aiden, are you here with us?
Yeah.
Okay, so do you agree that 5 as a string plus 7 as a string will give us 57, or will it give us 12?
It will give 57.
It's gonna look like 57, right?
Yeah.
When we run it, we get exactly that, 57. So just explain here to Ian, the reason why we get this is because when you add two strings together, you're not necessarily adding them. It's what we call concatenation. Concatenation, it's just a fancy word for combining. So if I have, for example, let's say my name, Rafael Almeida, right? If I add those two and I run it, I get Rafael Almeida combined. Okay? That's one thing to take note of, is that certain operations with strings are different than with integers. Now, in the case of multiplication, this is the only next one that will work. So if I have, for example, Rafael, and I do that times 5 as an integer, it has to be an integer. What will I get? Does anyone know? What's going to show up over here?
It's going to repeat it.
repeat it.
Oh, not sure.
You're not sure? Okay, we'll see, we'll see. Aiden, what do you think?
Probably repeat, but I haven't done anything of multiplying print statements. Multiplying strings, I mean.
Yeah, yeah. And you guys can try for yourself right there on your own trinket. As you guys try that, I want to see the turtles. Turtles are still racing over here, tirelessly. Seems like green won that one. Let's see. I'll keep it on the side. I'll keep it on the side. No, actually, I'll keep it here, and then I'll get the turtles to be right here so we can see them. Anyways, so what do we get? We get Rafael, 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 and they're all just munched up together, like combined together, and that's what we expected. So multiplication and addition work differently for strings. That's something to take note of. If you want to remember that, you can just write it on the side, write it on a paper, because that's going to be relevant to what we're going to be doing. Next, I want to introduce an idea of what we call casting. Okay, casting, think of it, does anyone know what a cast is? Aiden, can you give me an example? What do you think is a cast when you think of that word as a noun?
A brace.
A brace, okay, okay. I think of it like a mold, like something you can use to mold and build, right? So the idea here is, let's say I have an integer, right? And I want that integer to become a string. Instead, let's say I can't add quotes around it. What I do is I cast it, right? I think of it as a mold, right? So I have like a bucket, and it's the shape of a string, and I get this number, and I shove it in there, and it becomes a string, right? It's gonna be the same. How do I say it? Not necessarily value, but it's gonna look the same to us humans. So 5 is a number and 5 is a string. They look the same, but they have different properties. So I'll show how that works right now. So let's say I have, let's say print. I want to print something to the screen. I have 5. So I got 5, 5 plus 5, I'll get 10. But what if I want to get 55, right? What if I want to get 55 by adding 5 plus 5? I can do string concatenation. So I can just make this become two strings. So then it becomes 55. But there's another way of doing that, which is by using another function. And the way we call functions, if you remember from the beginning, is we type the name. So the name in this case is str for string. We open and close parentheses. Okay? Then we put whatever we want in there to become a string. So we put 5 and then we add 5. We call the function again, call the name, open and close, put 5 in there. What am I gonna get? I get 55. So let me change it so that it updates down there. So I get 58, for example. So I was able to change the shape, the type of that value, right? And similarly, we can convert strings, if valid, if they are convertible, right, to integers. So let's say I have the string Rafael, right? Well, just my name, just keeping it basic. Can I convert this to a number? Not really, because Rafael, it's not like a it's not 0, 1, through 9. So if we have a string which is a sequence of all those numbers, right? All those like 0 through 9, it could be anything. We can actually come here, type int, open, go all the way to the end, close, and if I print this, right, I get that. But it's not very useful to us. Let's say I want to add 5 to it. Now I run, you see I added 5. But if I had this as a string still, not as an integer, without converting, I get an error. It says that I cannot concatenate string and integer. I cannot combine them. That's also something important to keep in mind. Certain operations can only be done with the same data types. Okay, next thing. So guys understand data types, printing, and casting. Casting is changing the type of the data. Now, we're going to introduce um, the input function. Okay, but before we introduce that, actually, I want to introduce the idea of variables. So can anyone tell me what a variable is? When you think of variable, Ian, when you think of that word, what comes to your mind of a variable?
It varies.
It varies, okay, it varies. Can you add something to that? That's correct. But can you add something to that? What do you got for us, Mr. Thomas?
Store a value and
Store a value in it. So a variable, you can think of it as like a name or a letter, something that we can reference it to, like call it by, right? And inside of that variable, it has some kind of value, okay? You can think of a variable as a bucket. Oh, well, let's say since we use a bucket for casting, let's say it's a box. And then on the label of the box, that's the name of the variable. And then inside of it, we can put any value we want, any value. It doesn't matter. So let's say I have a variable. How do we define variables in Python? So in the case of JavaScript, as some people here may have an experience, you have to first define the type. What data type is that variable going to hold? In Python, you don't have to do that. All you got to do is type the variable. Let's say I have a variable called name, okay? And I want name to be equal to a string, so I open and close the quotes, and that name is going to be Rafael Almeida. It's going to be my whole name. And then let's say I have another variable called age, and that age can be my age. It could be 16. I want you guys to follow along just to see how this works. So now I have all these variables, and if I run this, I don't see them. Right? How come I don't see them? Like I wrote them here, I don't see them. That's because you have to print them. And I forgot to print. So I can print my name, and I can print my age. And they will be in different lines here, Rafael Almeida and 16. But what if I want to have all this information in one line? If you guys remember, we can add things together, but I can't just quite add name and age and get the result I'm looking for. Because if I run this, it's gonna give me an error. It's gonna say I can't combine strings and integers. That's because name is a string, as we can see here, it has quotes, and age is not a string. Now, how can we make age a string? Pikachu, can you tell me?
You do the str one, like before you.
Exactly.
Yeah.
Yeah, good job, you got it. So we type str, right? Open and close, and we type age. Now, if we run this, we get Raphael 16, but like it's all, combined. It has no space in between. When we can solve that is by, let me put some space here. I first want to create a string, and I want to make it a simple blank space. And then I'll add that again so I got name plus a space plus my age as a string. If I run it, I get the exact result I was looking for. So, okay, covered a lot. Does anyone have any questions on how this all works? So we got data types. We got uh we got the print, we got variables, and we got casting, which is converting. No questions so far? Great. Because I'm sure you guys are gonna have a few questions now because I'm gonna introduce something that's somewhat difficult to understand. So, I'm gonna introduce the idea of conditionals. Condition. Ian, what do you think of, like, when I say the word condition, what do you think of? Ian, are you there? Ian? Okay, well,
I'm here.
oh, you're there?
Yeah.
Okay, okay. Okay. So, when you think of the word condition, what comes to mind?
Um,
Condition.
like if a plate is like slightly like cracked and stuff, like condition like that. Like if
Mm-hmm.
something's broken down or not.
That's
I
a
was trying to
condition.
talk, but I thought my sound was on.
Oh, no,
Sorry
don't
about
worry, don't
that.
worry. Okay, so a condition is, you can think of it as the state of something, right? The situation of something. So the plate in that case has a broken condition, a broken situation. And in Python, we can represent that idea. We kind of can. So um, when we know of a condition of something, we can, right after that, make a decision. So if plate is broken, buy a new plate. If plate is not broken, use the plate, right? And um, in Python, we can represent the same idea. So let's create a variable, for example, let's call it plate underline underscore, right? Situation is equal to a string that's called broken, okay? And if we print plate situation, what do we get? We get broken. So the plate is currently broken. And how can we tell Python to do something given that information? We can simply say if space plate situation equal broken, I want to do something, right? And you maybe wonder, oh, why did you put two equal signs, right? I, what you're pretty much doing is checking if the play situation is broken. Why do you have to use two? That's because in Python, one equal sign is used to tell that something has that value. Is to assign that value to something. Give play situation the value of broken. Now, double equal sign is used to check if play situation has that value. Are they equal to each other? Okay, and then right after that, what can we do? We can say print open, close, right? Remember to open and close your parentheses, open and close your quotes. Buy a new plate now. Now, right? If somebody eats on that broken plate, they may get like shards in their mouth. That's not fun. So, the reason why this print is a space in under the if, that's because whenever we type if, the Python is expecting an what we call an if block, right? It's expecting an if block, and the way we define a block is by indenting it right under of such condition, right? So if I have something that's outside, it's not inside of the if. You can think of it like an umbrella, right? It's inside. So this is on the outside, this is on the inside. And if I type something here, print, this is on the outside. And I run, we see that it says buy a new plate now, and this is on the outside. So Python came here and it was like, okay, plate situation is broken, so I want to buy a new plate, and this is on the outside, so it doesn't really matter. But let's say the plate situation is not broken, okay? And if we run this, you see that Python doesn't tell us to buy a new plate because the plate is not broken, so it's completely fine. So this idea of you can check if a certain variable has is equal to something you want, it's very, very powerful. Like the possibilities of the stuff we can do increased by a lot. And remember the calculator program, I can go back to it here real quick. Let's get rid of these turtles. So I'll have here the calculator. So calculator asks for a number, then it asks for an operation. Let's say subtract. And let's subtract 2 from 5, and it gives 3, right? How do you guys think we can use the idea of conditionals in our final project here? Idea of if. Does anyone have any idea?
For instance, if you type yes, it would say think it's if. If it typed yes, it would ask for another first number, and in the another if for the enter operation part.
Good job. That's exactly what's going to happen. So, inside of our program here, we're checking if the information of the user wanting to continue, we're going to check if it's yes or no. If it's yes, we continue. If it's no, we stop, right? If I say yes, you see it asks for a first number, just like Pikachu said. So enter first number, we can enter another one. Please enter an operation. And how can if be applied to this part over here? Does anyone have any idea? Aiden, do you know how many what we just learned, the idea of conditionals of if something happens, if it doesn't happen?
Yeah. We can do like if the operation is add or subtract, and if yes, then
You got it. You got it. Yeah, that's it. So what Aiden was trying to say is that um, if we type add, division, or multiply, our program is going to check, oh, is the operation add? Okay, if it is, add. If it isn't, then we do something else, right? We do whatever it is. And you guys got it, man. Oh my God, man. I got these geniuses in my class. It's so good. So, next thing I want to introduce. So we got if, um, and what the thing I want to introduce next is else. So let's go back to our plate idea here. So, okay, okay. If play is broken, um, we say buy a new plate. But if the plate is not broken, how can we represent that idea? It's just like in common English. So if plate situation is equal to broken, buy new plate now. Else, do whatever. Maybe get the plate to eat. So we can express the idea of if something is going to happen, like if that thing doesn't happen, then what do we do next? We can do that by typing the else keyword. Oh, and I forgot to mention that you cannot forget the colon at the end. Do not forget the colon. So we go enter, else, and okay, so if plate situation is broken, then we buy new plate. If it's not broken, then print the plate is good to eat. Okay, now we can run. The plate is good to eat. Okay, but it might happen that our plate is dirty, right? It's not broken, but it's dirty. And there's no in between here. There's no way our program can know, is it broken? Is it not broken? Is it dirty? Is it clean? So let's say that our play situation is dirty. All right, we'll change this to dirty. So if we run this, it's gonna still say that the plate is good to eat, but it's actually not. Then how can we express a midterm idea here? And all we gotta do is combine if and else. When you combine those two things, it becomes elif. So if plate situation is equal to broken, we buy a new plate. L if, which is pretty much else if, but we shorten it to elif. Plate situation is equal to dirty. You want to say print that is nasty. That is nasty. Go wash that plate, right? So now if you run this, it says that is nasty. Go wash that plate, right? So we now have the idea of if, elif, and else, and we can change the situation of the plate. So let's say the plate is clean. The plate is good to eat. If the plate is broken, buy a new plate. And if the plate is dirty, you gotta wash that plate, right? And now we're gonna introduce the final thing, and then we'll finally get to. Actually, there's two more things I want to talk about, but let's try to make it brief. We're already a little. No, actually, we're not over time yet. Almost there though. So our turtles are definitely getting tired. Okay, I think purple just won right there. It's pretty cool. And these turtles don't stop. So let's just move on to the next idea. The next idea here is the idea of input. So input is another function in Python, and what do you what does the word input mean to you? Ian, what does it mean?
It feels like you could just input some sort of text inside, like input your answer.
Yeah, yeah, that's what I think too. And if you go here in our calculator, what is this? It's asking us for a number, right? It's asking us for an input. It's asking us to enter something. An input is pretty much that. So we're gonna um make that we're gonna call the function input. It's simply called input. We open and close parentheses, And then inside of input, we type whatever we want to ask for. So let's say I want to ask for, what is the situation of the plate? Okay. Then I want to put like a colon there and maybe a space so that it looks nice. And if I run this, you see that instead of assuming what's the situation of the plate, it's asking the user, right? So what is the situation of the plate? We can say, maybe it's broken, right? Maybe it's, oh, sorry, not here. You want to type it here. So maybe it's broken, and then after that, the program tells us what to do. And you may, start wondering how this is useful, like the amount of the possibility of stuff we can do just exponentially increased, right? Maybe we can code a program for a restaurant, right? Where the restaurant shows the program to play. The program is like, okay, that plate is dirty, go wash it, or that plate is broken, go buy a new one. And I mean, the possibilities are endless. And in the case of our calculator, we are going to ask for a number, actually two numbers and an operation, right? So with all this information, we can already start making our calculator, okay? So how can we start actually making it? Does anyone have any idea? Huh. So first thing I want to do is ask for a number, then ask for an operation, then I want to ask for another number, and then output the result. So what should I do first? Does anybody have any idea of what my first line should be?
I think it should be some variable equals input.
You got it. You got it, man. So some variable. What do you want to call that variable? Candace,
Yeah.
what's the name?
I think we should call it number one or number
Num.
one.
Okay,
As
okay. Let's call
someone.
it number one because we're gonna have two numbers, right? Number one and number two. So you want to make sure there's a difference there. So number one is equal to what? It's equal to an input, right?
Mm-hmm.
And then inside of that input, everybody's following? We are going to ask, what are we asking for?
What number the user wants.
Okay, yeah, so enter number one, right? Then we add a little colon, a little space, because if you don't do that, look what actually happens. Sorry. So if we don't, oh my God, change this, let me run. So it doesn't look very nice. Like it just, everything is like together. So we want to add some kind of space in between that. So when we run it, sorry, when we run it, it has like a distinction between what's the question, right, and what the user is entering. So right here, let's say 132. But we're not doing anything yet with the number, so we got to do something with it. But before we do that, we got to ask for an operation, right? And how do we do that? How do we ask the user for an operation? What's the next line here? Aiden, can you help me out here? I'm a little confused.
Hmm. Uh, you use an if statement to check if there's an input, and then get then you ask for the second input.
Okay, okay. So you don't, that's correct. We gotta check if what the user input was, but we're not gonna do that yet. So the first thing we want to do is ask for another input, right? So when we run this, it automatically asks us for an input, and then we can enter whatever, even if it's not a number, and then our program ends, right? And I believe this should be clear. Okay, so it cleared. Anyways, so the next thing we want to do is ask for an operation. So I'll create a variable called operation, right? Do you agree that's a good name, Aiden? Would you call it that?
Yeah.
All right. And then, all right. So then how can I ask the user for an input, Aiden?
Uh, just do input again.
Input again. Okay. And what do I put inside of input? Oh, sorry. What do I put in
Enter
here?
number two, right?
Number two? You think it's number two? It's not quite.
Oh,
We're not asking for that yet.
oh yeah. Um, what mathematical operation? Or enter
Exactly.
mathemat.
Yeah. Perfect. You got it. Enter operation. We'll just say operation to keep it short, right? You don't want to go too advanced with mathematical. And as Aiden was saying, what should be the next step? Aiden, you already explained to us in the previous step.
And then if number one is a um integer, then you check what operation is, and then you run whatever.
Mm-hmm.
Then
I
and then
understand, I
you
understand. Yeah.
yeah, and you
But
ask
we
for
don't have
something
two
else.
numbers yet, though.
Yeah, we had to ask for a third number, a second number first.
Yeah, yeah. So how do we do that?
Number two is equal to input enter number two.
Okay. A professional already. Enter number two. I thought you said you didn't have a lot of experience.
Well,
That's quite some
Lua
experience you got.
programming kind of translates over since print statements and stuff.
Yeah, yeah. I feel you. Okay, so we got number two. Now we have all those numbers, right? And maybe we can do something with them already. We can get number one plus number two, right? So we'll just ignore operation for now. And I just want to check what happens if I add number one and number two. If I run this, um, Mr. Thomas, can you pick a number for me?
4,
Four. Operation, it doesn't matter. It doesn't matter. And what's gonna be our second number?
12.
12. Okay, if we run this, what do we get?
Error. It errors because it's not, I mean, that should be fine. It should add 4 and 12 because you're not really using the operation yet.
You,
So it should give 16.
you think so?
Yeah.
Let's see, let's see. Where do you guys place your bets? Aiden, what do you think is gonna happen, Aiden?
I'm gonna place bets on my dad because he's done Python before for a while.
Okay, okay. That's fair enough.
Uh, well, I bet that it's gonna say 16.
16 as well, okay, so and Pikachu, finally, what do you think?
I still think it's 16.
You think it's gonna get 16? I'm not gonna
Yes.
say anything.
We're all placing bets on my dad's answer.
Let's see, let's see. Maybe I'll make a few bucks here. We get 412. Huh.
So they
No.
were input as strings, and you need to say int first on each one.
Mm-hmm.
You
Exactly.
haven't cast them down to integer yet.
Exactly. So everybody understand that idea that input, whenever we ask the user for an input, we're always asking for a string, right? And even though number one may look like a 4 to us, for the computer, it doesn't necessarily work like a normal 4, right? If I say 412 to the computer, it's going to understand, literally 4 and 12, right? It's not going to understand the number 12, the number 4, combine them to get 16. Before we can do that, we must first cast into an integer. So we put this whole thing, right? This whole thing inside of parentheses. So we have a parenthesis at the end, we have an extra one at the beginning, and then we have int, right? We don't have to do that for operation because the operation is not an integer. But we do have to do that for number two. So we do the same thing. Everybody follows? So now, if you do the same thing, doesn't matter, right? I see you even spelled it wrong because it doesn't matter. If you put 4 and 12, now we'll actually get 16. Okay, so that's pretty great and all. So now our stuff is actually working. So on top of adding, we can multiply. So we can have 4, if we just skip this, and 12, we're gonna get 48. It's working just as we want it to. However, uh, it's not necessarily doing the operation that the user is asking for. And how can we check, right? How can we decide on what to do next, given that the operation is something, right? Ian, can you tell me?
Um,
So think of it
I can't
like
really
the
say.
play. No, no, that's completely fine. So let me help you out here. Um, think about the play situation, right?
Hmm.
What was the situation of the play? It was broken.
Broken.
Okay.
And then you changed it to non-broken.
Yeah, and then I
But
changed it and
the
whatever.
first thing, the original thing was broken.
Yeah, you got it. So if the situation of operation, the situation of, so the situation of this, if that situation, right, which is this, is add,
Hmm.
how do we check if it's add or not?
Um, Operation check something.
Okay, and what's the keyword for that? How would you ask that to
Mm,
someone? We could say, for example, if operation is equal to add, we add, right? Remember
yeah,
that?
yeah,
Remember we
kind
just said
of.
that? So, yeah, I want you guys to code with me, and maybe while I'm talking, even like code ahead if you want. But the idea here is that we're gonna use if. We're gonna tell the computer like if operation, right? So we have operation is equal equal. Remember the equal equal
Hmm.
is equal to add. We put the colon at the end, and then what do we do now?
Um, check. Um, Add if operation. Add check if plate is broken.
Well, in over here, we're not dealing with plates anymore. We're dealing with numbers, right? So if the operation is add, what do we do with that numbers? If the user says add number one and number two, what should the computer do?
Then it should add it together and put. Um, then it would just add it together.
Yeah, exactly. Just add it together. So if we have number one plus number two, do you think this is gonna work? This is gonna show us the result?
You need to print it.
We need to print it. Exactly. Mr. Thomas,
And
got it.
we don't really know what number one and number two is.
Yeah, not yet. But if we assume we know what it is, right? Let's just imagine it
Mhm.
was 4 and 12.
Then we could say 12, 16.
16. Yeah,
And if we didn't know what it was, like number one plus number two, we could say it's number three.
could. It could be. It could be.
Okay.
It doesn't matter. But the what I was trying to show here, Ian, is that if we add number 1 and number 2, but we don't tell the computer to show it to us, it's not gonna do that. So we have to tell, okay, I want you to print, okay, print number 1 plus number 2. So now if you run this, right, enter number 1, let's say, Ian, pick a number. What's your favorite number?
8.
8. And what do we want to do with it? You want to add, right?
Hmm.
And then what's your second favorite number?
6.
6. What do we get now?
14.
Exactly. So now all we have to do is follow this idea. So I'm gonna ask for someone to help me out on what to do next. Pikachu, can you help me? I love that name.
So I think you should put in a lift operation equals and then another operation subtract.
You got it. Yo, on the bullseye. You said it word for word. So let's say elif operation, right? Don't forget the reason why we use elif is because we want to add another situation. Okay? So you go elif is equal to what for example?
Um let's say multiply.
Multiply. Perfect. Multiply. And then don't forget our semicolon. And then what do we do now? If the user says multiply, what do we do?
Let's see. If the user says multiply, we should print and then do the parentheses number one multiplied, which is this asterisk time, which and number two.
Mm-hmm. That's exactly the word for word as well. Again, good job. So we got asterisk. We can add a space in between. We don't necessarily have to, but we can just make it look nicer. So now, uh, Can you test that program for me? Let's just say pick a number.
7.
7. Okay. And then what do we want to do? We want to multiply, right? That's what you just
Yeah.
helped me do. We want to multiply.
And then
Uh,
19.
19. What is it going to be? 7 times 19. It's going to be a big number. 133. Okay. So it's working, right? It's working as it's supposed to be working. Now,
Mhm.
Aiden, can you help me with the next step? What do I do? Oh, I kind of give you a hint right there.
Subtraction and division.
Subtraction and division. And how would I do that exactly?
You say another elif operation equal to divide or subtract.
Mm-hmm. Yeah, you got it. So elif operation, we'll do equal subtract first. So we're gonna print number, open and close parentheses, number 1 minus number 2. Now we can do the final one, which Aiden said, so it was division. So elif operation is equal to division. We can print number 1. Number 1 divided by number 2. So remember division is the um forward slash. Okay. Oh, take that out. So I would like everybody to copy this. Oh, and one thing I want to show you guys that's very cool too is the idea of comments, right? So whenever you're coding something and it gets really, really big and like hard to understand, you want to go on each step and explain what that step does. But we can't just simply type, oh, this step shows, this step adds the numbers, right? Because the computer is going to say that there's an error in our program. So the way we can tell the computer to not show an error is by using a hashtag in the front. And you see how our letters got like it changed colors? That's because the computer now understands that this should be ignored. So I'm just going to add a comment using a hashtag on top of everything that we just did so everybody can like copy it and understand later on in the future. So checking if operation is add. And now and here, right, we actually add the numbers. So then we check if operation is multiply. Now we check if operation is subtract, like Aiden told us to do. Now we check if operation is division. And here, what are we doing here? Can someone tell me what are we doing in this line? Just so we can recall it.
We're finding out number 1.
Fine, yeah. So we're asking for number 1. And what else are we doing, Ian? Is it
Finding number
anything else?
2. And entering an operation title.
Yeah. So asking for operation, and we're asking for number 2. But there's one thing I think we missed was what about this? What does this do? This int open parentheses and close parentheses over here. What does that do?
I don't know.
That casts it to integer.
Yeah,
Mm.
exactly.
Converts string to integer.
I haven't done this before, so it's kind of new to me.
No, don't worry. Don't worry. That's why we're commenting so you can remember. So here we're asking for number 1 with input, right? And now let me just add some kind of separation here. With int, right? With int open and close parentheses, we convert number 1 to a integer. Because remember how everybody placed their bets on Mr. Thomas and everybody said it was going to be 16, but it ended up being 4 and 12. That's
Because you
because,
didn't put operation in it or something in it.
yeah, we didn't convert it to an integer. We didn't convert it to to a number. So the computer thought that 4 and 12 were text, right? And when you combine text, you just put them together next to each other, right? Um, So we had to remember to convert int to we had to convert number 1 to an integer using int. So I'll just keep that there. And here on number 2, we do the same thing. So we asking for number 2 with input, and then with int, we convert number 2 to an integer. So let me just fix that. Gotta keep that grammar check. Programmers are, well, some of them. Anyways, that's besides the point. I think our program is pretty much done now. So we commented everything, what it does. So in the future, when we can come here and check exactly what it does. Oh, we can also say, do not forget to add a space under the if. Think of an umbrella, right? And in here as well. Now I think our program it pretty much works, right? Like number 1, we can say 10, and in operation we can say subtract, and we can say 5 and we get 5, and then we can run it again, and we could say any number, huge number. Let's multiply it by a other huge number. Does anyone know what we're gonna get? It's kind of hard to know, but we get this huge number as well. So anything works. Any number we put, any integer, uh, any of these 4 operations, it's gonna work perfectly fine. But we're missing one thing. What are we missing? Does
A
anyone know?
prompt to ask if you want to run it again.
Exactly. Mr. Thomas got it. So, um, we want to ask for the user. We want to ask the user if he wants to do this all again, right? And I didn't introduce this idea yet on purpose so that we can discover it now together. So, the thing here is you can think of the computer asking the user, right, over and over again, like, do you want to do this? Do you want to do that? Is like just keep repeating stuff. We can think of it as a loop. What do you?
Like if you were going to like a Nearpod thing for homework, that's what I do at school on a Nearpod. And at the
Yeah,
very end, it says start over, like go back to the beginning.
exactly.
And in some
That's
games and stuff, once you complete it, it says start over. Yeah.
So if you're playing, I don't know, any game. So Aiden, Aiden plays Roblox. I know. If you press ask, right, to open the menu, you can reset your character, right? So it goes back and recreates your character, right? And the way we can think of that is a loop. And a loop is just something that repeats over and over again. And the way we can represent a loop that repeats forever in Python is by typing the keyword while, and then right after that we write true with a capitalized, right? Capital T, R-U-E, and don't forget to put your colon at the end of like every statement. And then what do we want to repeat, really? I feel like we kind of want to repeat everything. So we got to make sure we add a space behind every single thing once. And if we do that, so can't forget this one. This one has to be twice inside, right? Because if you think there's like a huge umbrella here, and then this is like a smaller umbrella, and then this is like what's under the umbrella, it has to be 2 times in, right? 2 times inside. So we can do that for everything else. Oh, I forgot this. There, there, and there. And what's going to happen now is the computer is just going to repeat this forever, endlessly, right? It's just going to repeat forever and ever and ever. And if we run this, it kind of works, right? So enter number 1, and then we can add, and then we can 5, and we get it. But then it automatically asks us for number 1 again, right? So the user is kind of trapped in here, like just endlessly adding, multiplying, subtracting, dividing numbers. That might get a little boring, so the user might want to leave. Oh, another example of a loop. Let's go back to our turtles. They're still racing. And how do you guys think that works, right? It's a loop that tells the turtles to race again and again and get into their position and race again.
So what I'm wondering, so it just goes to the end of the page that we can see, and then that's the end of the program. So it just immediately it's a loop and it starts over.
And it starts over. right?
And how does it control like which one goes like is in lead and stuff?
Sorry, can you say that again?
How can you program it to see if like if one turtle is faster because it changes for every single round?
So one way you could know if a turtle is the fastest is how many times it won, right? And that's in our little file results there. We're gonna see whose turtle was the fastest. Can you see that red? I mean, not red. Green and blue. They're doing pretty well. Like blue just won again. Who was blue?
I watched my green one win 3 times in a row.
Ooh, orange won right now.
hmm
Orange was Aiden, right? Or was
No, I was
So
blue.
the purple
oh,
one,
okay.
it goes slow.
Orange was Pikachu.
Yeah, Pikachu. Okay.
Well, the purple one, it goes off a slow beginning, but in the middle it has like a huge burst, and then it like slows down toward the end.
Yeah, I mean each turtle is
And
different.
that's
I
good if
guess.
you're like trying to catch up and stuff.
Yeah. So I guess Mr. Thomas is
I was
turtle,
thinking the
right? You were
speed.
purple.
I was thinking the speed was like considering to how many letters the color had.
Mm, I don't know. Maybe. So
I think
in that
using a
case,
random integer.
yeah,
It is
that's more like
random,
it.
but I'm pretty sure orange.
Well, if that were true, then purple wouldn't be losing almost every
It's
round.
random, but orange has favorable random numbers. You can tell by it generally always wins.
Yeah. Yeah. I guess Pikachu got well, it didn't win this time. I think blue won. So, but I saw orange winning twice in a row. Because if it wasn't the case of the longest color, then purple would just be winning every time. And Mr. Thomas's turtle is a little I think it's a little chubby. It's ate a little too much, so it's not that fast. Look, orange again. Pikachu, lightning speed, right? Anyways, so we got the program and it just keeps going and going, but we never ask the user if they want to stop or not. And how can we ask the user to if they want to stop or not? Does anyone have any idea?
We use
At
the
the
map.
very end. Oh, no, sorry.
You go ahead.
Okay.
Okay, thank you. Do an operation and something like that, and put input or something like that, and then like you did for start over thing to loop it, you would say you would ask it if you wanted to stop.
Okay, yeah. Do you want to add anything to that, Aiden? So we can get both ideas?
No, I don't have anything to add.
Okay. Yeah, so he pretty much knew what we had to do now, so all we had to do is ask for another input as he said, like we did for the operation. So what can we call this? What can we call the decision of going again? Any name, honestly. Oh, okay. I'll just say again, right? Let's call that the user's decision of going again. Let's just call it again. And then we have to make again equal to what? What does again have to be equal to?
Input.
An input. So Thomas got it. So it's gonna be an input, and then what do we ask the user? So we open quotes, close quotes.
Start over or again.
Yeah. Uh, want to go again, right? And then we add a little thingy there, a little colon. Let's get a space. So again, input. Um, now what do we do with this, right? Like we know the user's decision to continue, and like how do we deal with it?
Need an if statement.
Doing an if statement. So, uh, since again is the user's decision, it can either be yes, no, or blah, 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 blah. Like the user could just slam his fingers on the keyboard and type whatever he wants, and we have to deal with all those situations. So, how can we deal with the situation of the user saying yes? How can we check if the user said yes? Pikachu, do you have any
Do
idea?
nothing. Do nothing.
Do nothing?
No idea.
I think you'd put operation, and then you would check like if operation or something like that. Like check if person did that.
Okay.
I think you.
So,
I think you should just do an if statement. If it is yes, then do it.
So they're pretty much the same ideas, and it's interesting how Mr. Thomas said we do nothing, right? So if the user wants to continue, we do nothing. Like what does that mean? And if you think about it, if the user wants to continue, all we gotta do is let him continue and leave it as it is. So we don't really have to do anything. In the only situation we have to do something is if the user says no. Because look, in the situation our program is in right now, right? If run, so we got 54, add, and I did it. Wait, let me restart. Uh, the run, got 54, add 6, right? And then it has to go again, but it doesn't matter what we type, right? It doesn't matter. It simply goes again. And I think that's what Mr. Thomas was trying to say and trying to tell us that if the user says yes, then it doesn't matter. Just keep going. If the user says something random, just keep going. Let's assume the user wants to continue. But the only situation where we want to do something different than keep going is if the user says no, says stop. So just like Ian and Pikachu said, the way we can check that is using if. So if again, remember again is the user's choice. If again is equal to no, then we stop. How do we stop?
Break.
Break. Mr. Thomas, I think you're cheating, man. I think you're cheating. Do you have a cheat? Do you have a cheat sheet on the side over there?
I
You
looked up
watching?
the answer real quick.
So it's it's very self-explanatory, right? So you look, use break to stop the loop cycle, right? It says right here under, and we can even type that right above. We use break to stop the loop. Okay? So right here, we're asking if the user wants to go again. And if checking if the user does not want to go again. The user doesn't, we break. And we have to know that break, you see how break is under this ifs umbrella? That's important because we only want to stop the loop if the user says no. If we were to have this break on the outside, on top of us getting an error, but because of the if on top, it would just stop. Even if the user says no. So, I mean, even if the user says yes to continue, no to stop, right? So now we can run this. It's running. Wait, let me just reset everything. Run enter number 1. We can say 5, and then we can multiply. Let's get, I think it was Ian's favorite number was 8. We get 40, right? 5 times his favorite number, so it's favorite, 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 favorite. And now it's gonna ask us to go again, and we can say whatever we want, really, and it's gonna go again. Because um, there's no situation in our program where we check if the user said anything besides no. So we only check if the user says no. Now we can say, for example, enter number 1, we can make it 5, we can add 8, we get 13, and want to go again? No, and it ends. And on top of it ending, we could, say a little message. So we could say print. So if the user says no, I want to tell the user, um, thank you.
Bye.
Thank you.
Thank you.
Thank you for using our calculator. Please leave now. Like, used it too much. Please leave. So it's as it is. And whenever we run, enter number 1, we got 5. Add 5. We get 10. Want to go again? No. Over. It's done. And that's it. That was our lesson for today. Um, we got the whole program done. We learned uh, data types, we learned print, we learned arithmetic, which is, simple operations. Then we learned concatenation, which is combining words. Then we learned how to cast, which is changing the value. And then we learned how to do a while loop, right? Over here, while loop. So type while true, and it's just going to continue forever. We learn how to break it. We learn input. If we learn a lot of things, so it might be a little confusing. Does anyone have any questions or like something you thought was really challenging today?
I don't think I have a question.
You don't, Pikachu? That's because you're just amazing, right? You Pikachu. So, Aiden, do you
Thanks.
have any questions?
No, I already pretty much learned this before.
Okay, what do you think is the hardest thing here for someone that already knows it?
I mean, maybe inputs and or maybe the while loop.
Maybe the while loop, yeah, yeah, because you have to make sure that everything is under the while loop's umbrella, right? And then if we don't tell the computer to break, it's just gonna keep going forever, forever and ever and ever. So
Yeah,
think of like if you go on a YouTube video, just loading screen, forever. So then we had to break. What do you think was the easiest, Aiden?
just printing numbers and
Yeah,
string.
true, true. I agree as well. Ian, what about you?
I think what my dad said.
What do you think was the hardest, Mr. Thomas?
I haven't used the input statement in so long, I forgot it accepts strings because I usually get input other ways, like out of a database or out of a field on a web page or something, and or I hard code it.
Mm-hmm.
So
And
that's good.
yeah, yeah. It's good that you got to relearn it. I bet you were coding in Cobalt like 20 years ago. So Cobalt is just another language, but it's very, very old.
Yeah,
Um,
it's too wordy.
yeah. So the input thing here is that input is a function that always returns a string. It always returns a string no matter what you type into it. And later on in the course, if you guys get in, it's gonna be amazing. We're gonna have such a good time. We're gonna learn how to make the turtles, which are still racing. Turtles are still racing. We're gonna learn how to draw stuff. We're gonna learn graphs. We're gonna learn a bunch. And we're gonna learn how to deal with more data structures and understand how these functions work, like more in depth, and maybe even create our own functions, right? Um, I guess that's it. Now we can maybe look at the results for the turtles. So I'll close this. I'll keep the turtles here. Does anyone want to keep going to maybe have a chance of winning? Okay, blue just won. Huh. Okay. Who do you guys think is gonna win? You could just shout it out. Who's gonna win? Purple just won. Aiden, who do you think is gonna win?
I still think orange might have more favorable odds.
Odds, okay. Ian,
I don't want to like be weird or anything, but like how normal people say they would always vote for their own, so I'm gonna say my own.
okay, okay. Your color was which one again? Sorry, I
Green.
forgot. Green, okay. Green just lost that one. I'm sorry, Ian. I'm not going for green. So Pikachu, what do you think? I mean, yours is orange. Aiden is
I'm
voting for
not really
orange.
sure. I'm pretty sure the code is probably going to be random, just changing by random. So I'm not sure.
Yeah, green. Maybe. What do you think, Mr. Thomas?
I think they'll be close to each other, but there may be a winner.
Think maybe a winner, like by one, maybe?
I mean, I don't think they'll all be even Steven, but I mean, I think they'll be really, really close because
Mm-hmm.
there should be an equal probability that they'll all get to win. But I mean, there isn't a perfect random integer generator. So
Yeah, that's true. That's true. So there's no way to generate like exactly perfect number. I mean, exactly perfectly random numbers, right? But for the more races we have, the closer those numbers are gonna get. How many races do you think these turtles went for? Does anyone have any idea? How many races maybe? I'd guess like 200 races.
At least 100, maybe, well, at least 200, maybe at least 300.
Yeah, I'm thinking 200.
At least 150.
150, you think a little less then? What about you, Aiden?
I'm doing some mental math right now.
Okay.
Wait,
Okay.
now more than 175.
Okay. So you added 25 to that. So I'm gonna
because
open the
it's still
results.
going. So
Oh, true. That's true.
Aiden's probably timing one and then dividing that into the length of the class or something.
Yeah. Oh, and we went a little over the time, right? But that's because there was a lot to cover. And it took a while for us to start, but I guess everybody's fine with that. So I'm gonna open the results. I made it so that I'm pretty sure. I hope it doesn't show on my screen, but I made it so that it wouldn't show. Okay, it didn't. Oh my god. Oh my god. Oh
I
my god. I
bet
gotta stop.
I bet it went for 720 times at least.
720.
Because I assume
Wait.
it's been running for an hour or
Okay. Wait. I gotta do the. I'm gonna put this calculator to the side so you guys can't see it. I wanna calculate first. Honestly, there would always be sort of. Oh my god, dude. How? So let me see. How many in total? How many did you guess, Aiden?
720 if it just went on for a single hour, but it probably went on for a little longer.
You were damn close. So close. 693 races
Ah,
in total. So close, so close. And it seems like everybody already knew. I think everybody already knew who was gonna win. Look at the results, guys.
Oh my.
no, I was
193.
last. Sad
I knew it
life.
had more favorable odds.
Wait, is this calculated by favorable odds?
I don't know. Let me make the numbers a little bigger. I have no idea because it's such Thomas Mr. Thomas thought that was gonna be somewhat close, but then like it's 40. It's a 40% like I mean 40 races above, right? And this one is like less than 10 races above.
Yeah, it's not very close, is it?
That's not very close,
Was
but
any of them have weighting factors?
I didn't code it. I didn't code it to be like that, so I
I know
hope it doesn't.
random
You should
isn't
have
perfect.
something like they had, like for instance, they should probably random have a obstacle, and that could be a weight.
Maybe. Or like each color to have some kind of property. Like purple is fat, like orange is faster, green maybe is fast for 2 races, but then it gets tired, so it has to rest. Should probably do that.
Orange is faster in the beginning of a race.
I think the purple, if you coded it right, I think it did good because on every single race, it would start out slow and then it would speed up really fast and have a really quick burst, and that would like propel it like half of the entire way, and then it would slow back down again. So
Yeah.
and then like it started
It
out
needs,
slow, so
it needs
there
to
would be
do
like
a
enough time for it to have a small break.
it needs to do like a quick acceleration at the end. I mean, if it did the middle, then it wouldn't do much because the others would just accelerate at the end instead.
Yeah, that's all true. That's all true, and it's all something we can work on maybe later in the course. In the few next weeks if we get to see each other, and then it's gonna be pretty cool. But I want to ask one last thing. Do you guys have any suggestions of how we can make our calculator better?
Maybe add some sort of turtle that draws out your numbers or something like that.
That's
Maybe.
pretty good.
Yeah,
That's
see,
pretty good.
on Scratch, you can make multiple clones and then use a sprite instead of a variable to show how many, so for instance, points you have.
Mm-hmm.
So you could possibly do that with the turtle.
We could. Anyone else have
I
any
think
other
we should
ideas?
change for how much it's running. Like instead of just straight up, you could change it so it's running around. And then like every single time it runs a full lap, then that counts as one.
Mm-hmm. Like yeah, like a track, right?
Yeah, and they would
And
each change speeds at different times. So it doesn't
mm-hmm.
really need like restart and go and restart and go.
It just goes and goes and goes, right?
Yeah, until
Oh,
you
okay.
stop it.
Like a Formula One car, right?
Like we said in this kind of.
Mm-hmm. And what about our calculator? How can we make the calculator better?
You could validate input so that if they didn't enter a correct operation, it would ask them again. Maybe
That's
put a
true. That's
while
true.
loop.
Maybe you could make it random. like
Make
the
it random.
a random
Everything.
operation. Though I'm not sure what command you can use.
No, there's a way to do that. Maybe I can show you guys real quick here. But but then how? I don't know if anyone would use that calculator in a test, right? But well, those are all great ideas of what we can do. But our class is like 40 minutes already over the time. I'm gonna stop sharing my screen here, and I wish everybody a good night. I hope you guys come back to us so we can, learn even more about Python, even get more in depth. And that's it. That's it for today.
Thank you.
Thanks, Rafael.
Bye bye.
Thank you.
Bye.